In this lesson, we're going to factor out a binomial factor as the GCF. In this example, we're going to determine the GCF of each pair of terms. So first, let's determine what are the terms. So here, anytime you have something that's separated by a plus or minus, it's a term. So here's the first term of the first example. And then you have the second part of that term. So that's two pairs. On the second example, that's a term. And then on the last example, you also have a term. So let's go back to our first term. In fact, let's play a game of I Spy. I want you to look at that first example there. And with these two terms, what is it that they both share in common? Well, if you don't see it, I'm going to highlight it for you. So what these two terms share in common, they both have, is a P plus Q. So notice here this first term, it has a P plus Q. The second term also has a P plus Q. So the GCF is the P plus Q. And what is left once you take that GCF out? Well, it's there in black. You have 6 minus R. And that goes behind it. There you have it. You've just factored out a pair of terms. Now, does it matter who's first? No, it doesn't. If you think about it, 3 times 5 is 15. If I switch it and write it the other way, 5 times 3 is still 15. So recall that for multiplication, order doesn't matter, which means it doesn't matter if you put P plus Q, that parentheses in the back, and then put in the front 6 minus R. It does not matter as long as you keep the groups together. The P must be with the Q and the R must be with the 6. And that is how you factor a pair of terms. Now, take a look at the second example. I want you to spy it. I spy another GCF, something that both terms have in common. Do you see it? What is it? Well, if you said y plus 3, then that is correct, because look at the first group. It had a y plus 3, and the second pair of terms also had a y plus 3. So that is my GCF. And what is left once you take that GCF out? If you said y to the 4th power minus 4, then that is correct. And there you have it, factoring out the GCF from a pair of binomial factors. I hope you love I Spy just as much as I do. So what I want you to do is I want you to see if you can spy the GCF of both of these examples. Find out what the GCF and what would be left once you take that GCF out. So let's start with the first one. What's the GCF? If you said x plus y, you got it. And then what's left once you take that out? If you said a plus b, awesome. Let's do that last example. Do you spy the GCF of those two terms? Hopefully you said 2x minus 3y. I know you did. Yes, I heard you. Now, once you take that out, what is left? You got it, 6m minus 5, and there you have it, factoring out the GCF.